This was humanity's first direct dive into Jupiter, and you might think the real story is what it discovered. But no, the terrifying part is how it died. In 1995, NASA launched one of the boldest missions ever, the Galileo probe. From the very beginning, this was a one-way journey. 147 days before impact, the orbiter and probe separated. With explosive bolts firing, the probe spun away like a bullet, locking onto a target 81 million kilometers ahead. Everything depended on precision. Too steep, and it would burn up before sending anything back. Too shallow, and it wouldn't even enter Jupiter at all. From that moment on, there was no turning back. The probe drifted alone through space, heading straight for the largest planet in our solar system, carrying humanity's hope to capture data never seen before. 14 days after separation, the orbiter fired its engines and changed course, leaving the probe behind on its final, doomed descent into Jupiter. Because the one diving in wasn't the orbiter stayed far away, acting like a relay, receiving data from the probe and sending it back to Earth. 9 days before entry, the orbiter locked its antenna onto the probe. Once the probe plunged into Jupiter's atmosphere, it would only have a few minutes to transmit. If the signal failed to connect, everything would be lost forever inside Jupiter. 6 hours before entry, the probe finally woke up. Instruments that had been silent for nearly 10 years powered on again. That moment marked the true point of no return. It had entered Jupiter's inner magnetosphere. This was a completely unknown region, packed with intense, high-energy particles. A violent, unforgiving environment unlike anything previously explored. The first system to activate was the high-energy particle detector. The moment it came online, it began recording data at an incredible rate, capturing up to 3 million particles every second. And while it was busy sensing Jupiter's fury, another instrument switched on too, because scientists had long suspected that lightning might exist deep within Jupiter's atmosphere.
That suspicion actually dates back to Voyager 1, when 2 nighttime images of Jupiter hinted at something unusual. But here's the problem. On Earth, lightning is closely tied to the ground. Jupiter has no solid surface. So does lightning even exist there? And if it does, how could it possibly form? At the time, no one had a clear answer. So the probe started listening. Behind its heat shield, a small window opened, allowing one instrument to monitor Jupiter's internal radio signals. If lightning existed, it would leave behind unique electromagnetic signatures. But radio waves alone weren't enough. Scientists wanted visual proof. That's why the probe carried 2 ultra-sensitive photodetectors, each paired with a fisheye lens and positioned 180 degrees apart, maximizing their field of view. If lightning flashed anywhere around it, they had a chance to catch it. 3 hours and 4 minutes before entry, the probe was just 360,000 kilometers away. It began measuring Jupiter's intense radiation belts. Over the next few hours, the instruments cycled through observations again and again, gathering as much data as possible as the probe raced closer. Then, at T-minus 16 minutes and 38 seconds, Jupiter began to fill the entire sky. In the final moments, Jupiter filled the entire sky. The probe began recording everything around it, non-stop. 3 minutes before entry, the orbiter, still flying high above at 214,000 kilometers, executed a new set of commands. Its onboard tape recorder spun to life, ready to capture every bit of incoming data. Below it, the probe was already falling. Like a dart thrown at a massive target, it had traveled nearly 800 million kilometers, and now it was about to hit dead center. Its speed had reached a staggering 47.4 kilometers per second. The probe itself wasn't large, about 1.24 meters wide and 86 centimeters tall, but it weighed almost as much as a vending machine. It was built in 2 parts, an outer shell designed to survive the initial inferno, and an inner descent module carrying the real instruments. That outer shell had one job: endure Jupiter's brutal atmosphere and slow the probe down. Only then could it deploy its parachute and continue the descent. But here's the most terrifying part. Jupiter has no surface. There is nothing to land on. No ground, no solid layer, just endless storms of gas, crushing pressure, and a descent with no bottom. On Jupiter, altitude isn't measured from the ground because there is no ground. Instead, It's defined by pressure. Scientists set the level where pressure equals Earth's sea level atmosphere as level 1. When the Galileo probe dropped to about 450 kilometers above that level, it was officially inside Jupiter. The moment it hit the atmosphere was incredibly dangerous. Its entry speed was only 4 kilometers per second below the absolute design limit. Just a little faster, and it would have burned up instantly. As it plunged in, it became the first human-made object to truly pierce Jupiter's outer atmosphere, sampling a world no one had ever touched before. The instant it entered, its atmospheric instruments came alive. They began recording temperature, pressure, and acceleration as it descended, because from that point on, it wasn't in space anymore. It was falling through layers of Jupiter, each more extreme than the last. Right at entry, the outer surface temperature of the probe had already reached 352 degrees Celsius, hot enough to destroy its delicate instruments in seconds if the heat shield failed. At that point, the probe had only one hope: that its heat shield would hold. The shield was built in 2 parts, a massive front heat shield and a thinner rear shield. The front alone made up nearly half the probe's total mass. Its tip was made of a special carbon-based material designed to burn away as it absorbed heat, basically sacrificing itself to protect what was inside. 35 seconds after entering Jupiter, the real violence began. In just 15 seconds, the probe endured a crushing deceleration of 228 Gs. In that brief moment, it plunged 230 kilometers deeper. This should have been the cold upper atmosphere, but instead, the heat was beyond extreme. The temperature at the front of the probe surged to more than twice the surface temperature of the sun. At that point, it no longer looked like a spacecraft. It looked like a man-made meteor. The heat shield began to crack and peel away, trailing a glowing stream of vaporized material behind it. Then, at 1 minute and 20 seconds after entry, everything changed. The most brutal phase of deceleration was finally over, but it came at a cost. The front heat shield had been eaten away, losing nearly 90 kilograms in under 2 minutes. Now it was time for the parachute. The probe had slowed to a speed where deployment should have worked, but right at the critical moment, around 0.18 atmospheric pressure, something went wrong. The parachute didn't open. 2 switches had crossed wiring, throwing off the entire sequence. Everything it had survived, the heat, the crushing deceleration, might have been for nothing. The probe kept falling. Pressure kept rising. 0.18, 0.28, 0.38. It just kept dropping straight down into Jupiter. Then, at around 0.418, something incredible happened. It came back to life. A cable snapped, the cover blew open, and the small pilot chute was pulled into the rushing airflow behind it. Moments later, the main parachute was dragged out and deployed. At 2 minutes and 52 seconds after entry, the rear heat shield finally detached, falling away into the rapidly cooling wake behind the probe. And suddenly, the temperature around it had dropped to minus 145 degrees Celsius. Now the probe was just 23 kilometers above Jupiter's level 1. The pilot chute violently pulled out the main parachute, which deployed and stabilized the descent. In just 1.2 seconds, the system completed separation, splitting the descent module from the deceleration module. And remember, this all happened at nearly 0.9 Mach. That parachute had to be incredibly strong, built from materials like Dacron and Kevlar to survive the force. 9 seconds later, the front shell was blown off and discarded. Only then did the Galileo probe truly begin to float in Jupiter's sky. Not landing, because there is no ground, just drifting deeper and deeper into an alien world. Next, a new set of instruments came online. A metal probe extended outward, beginning to analyze Jupiter's clouds kilometer by kilometer, trying to understand what they were made of and how they behaved. With the outer shell gone, the real descent module was finally fully exposed to Jupiter's atmosphere. 3 minutes after entry, as the discarded shell drifted about 30 meters away, the remaining scientific instruments began waking up one by one. The descent module carried just 7 main instruments. That was the whole point of this one-way mission. Every bit of data it collected had to be sent to the orbiter above and then relayed all the way back to Earth, nearly 778 million kilometers away. And yet, all the instruments combined weighed only 28 kilograms. At this point, the probe was about 21 kilometers above Jupiter's level 1, falling at around 650 kilometers per hour. As the main parachute fully caught the atmosphere, its speed dropped further to about 430 kilometers per hour. Then, At 3 minutes and 2 seconds after entry, the first direct sampling of Jupiter's atmosphere began. Pressure 0.428 atmospheres. Because of the earlier parachute delay, this moment came later than planned. As it collected samples, the probe was also desperately searching for a signal from the orbiter, because if it couldn't connect, everything it was discovering would be lost forever. Then, about a minute later, it finally locked on. By that time, it had fallen another 4 kilometers, and in less than 30 seconds, the pressure surged from 0.428 to 0.568 atmospheres. Jupiter wasn't just getting deeper, it was getting heavier. At 4 minutes and 8 seconds, the orbiter finally received the probe's signal. Within seconds, everything was transmitted, both the stored backup data and the live measurements. The Galileo probe had already passed through more than 450 kilometers of clouds and gas. As it crossed Jupiter's level 1, it had, in a way, reached the planet's surface. But this was only the beginning. The extreme cold of the upper atmosphere slowly gave way to rising heat. Temperatures climbed from minus 135 degrees Celsius to minus 107 degrees Celsius, still freezing, but now the trend had reversed, and it would only get hotter. By 9 minutes and 36 seconds, the temperature continued rising. At 1.68 atmospheres, it had reached minus 80 degrees Celsius. But this was just the start of something even more important, because the probe wasn't only studying Jupiter, it was also searching for clues about the early universe. Then, as the external pressure hit 2.58 atmospheres, a critical moment came. Inside one of its key instruments, a delicate platinum membrane suddenly ruptured. Then the real chemistry began. A reference gas was released, mixing with Jupiter's atmosphere, starting a precise measurement process. The reason was simple. Hydrogen and helium are the most abundant elements in the universe, but their exact ratio right after the Big Bang is still one of the biggest questions in cosmology. And Jupiter? It might be a giant time capsule, preserving that ancient ratio. If scientists could measure it, they wouldn't just understand Jupiter better, they might get closer to understanding the birth of the universe itself. At 22 minutes, the first full round of chemical sampling was complete. By then, the pressure had risen to 3.88 atmospheres. As the probe descended into the predicted water cloud layer, the temperature reached 0 degrees Celsius, and it had fallen 56 kilometers below the reference level. But the deeper it went, the stranger things became. Temperature shifts started creating complex layers of heating and cooling. These differences drove violent atmospheric flows, powerful enough to control Jupiter's entire weather system. So another set of instruments activated, measuring heat flux and radiation, trying to understand how these massive, chaotic currents actually worked. A small optical sensor extended out from the probe, peering through a tough diamond window into the harsh radiation outside. To prevent moisture from condensing on it, the system even carried its own heater. Because Jupiter's atmosphere changes with depth, a second round of sampling began at 8.68 atmospheres. By design, the Galileo probe only needed to survive to about 18 atmospheres to complete its mission. That's roughly 35 minutes. It was never expected to last longer, but it didn't die. At 41 minutes, it was still transmitting, like a machine already sentenced to death, somehow forcing itself to keep going. Using this borrowed time, it completed the second round of chemical sampling at 12.18 atmospheres. Then, at 49 minutes, it was still descending, deeper, hotter, more dangerous. At 15.88 atmospheres, scientists even initiated a third round of sampling. At this point, the logic was simple. If it's still alive, keep collecting data. But Jupiter doesn't show mercy. At 51 minutes, one of the transmitters failed. The probe had been designed with redundancy, 2 parallel data channels, to avoid a single point of failure. But now, the end was getting closer. Now, one channel was gone. Over the next 12 minutes, the remaining transmitter began to struggle, its signal flickering, cutting in and out, fading, returning, fading again. It was a clear sign the sealed electronics box was starting to deform under the rising heat and crushing pressure. Then, after exactly 1 hour, silence. The mission ended, not with an explosion, but with disappearance. By that point, the internal temperature had reached 153 degrees Celsius, and the probe had descended 146 kilometers below Jupiter's reference level, far deeper than anyone expected. 20 minutes later, the orbiter shut down its receiver, folded its antenna, and continued its own dangerous journey around Jupiter. But for the probe below, the real end hadn't come yet. Deeper down, The environment becomes so extreme it can vaporize metal. As it kept falling, Jupiter began to tear it apart. First, the parachute melted away. Then, without any drag to slow it down, the descent module dropped into freefall, plunging into a world where nothing survives. Aluminum parts melted first. Within hours, even the main aluminum structure was completely vaporized. 4 hours later, the inner titanium shell and all the instruments inside began to melt away. 2 hours after that, in an environment of 1,700 degrees Celsius and pressures 5,000 times Earth's surface, even the strongest materials couldn't survive. Everything was gone. No wreckage, no crash site. The Galileo probe didn't just break, it was atomized, becoming part of Jupiter itself. Humanity's first visitor to Jupiter's depths lived only briefly, but brilliantly. In its final moments, it sent back answers to Earth, then vanished forever into the planet it explored. And just like that, it became a tiny piece